Good morning, everyone, and welcome to KETIV's Autodesk Virtual Academy. I'm Nigel Mbayak here. Sorry you can't see me on the camera. We had some difficulties with the video this morning, but I assure you I am here and not a robot today. Today, I'm joined by Thomas Fitzgerald from Autodesk. How's it going, Thomas?
It's going very well. Thanks, Nigel.
Definitely. So as you can read here on the screen, today we're going to be going over some more design automation using iLogic in Inventor. And this happens to be the fourth part in this series of webcasts. So if this might be your first one, you missed the first three, definitely keep watching. But if you need to catch up at all of those webcasts are on our YouTube channel. That's youtube.com/KETIV Technologies. Definitely iLogic's been one of the biggest things over the last 6 months here at KETIV. We've had a lot of engagements with customers. I'm sure some of you are on the call right now. And it's becoming a huge part of the industry moving forward. We all want more engineering time. We all want to be able to innovate more and not necessarily spend time on some of these repetitive tasks. And iLogic and leveraging the Inventor API is just one way you can do that, among others, things like data management as well. So with that, I think I'm just going to go ahead and pass it on to Thomas. If you do have any questions at all, anybody, go ahead and type them into the chat panel at any time. We'll be able to address those either during the session or at the end in our dedicated Q&A session. So with that, Thomas, if you want to take it away.
All right. Thanks, Nigel, very, very much.
No problem.
Good afternoon, good morning, anybody who might be on the call. Today, we're going to be talking about part 4, working with developing logic within iLogic using the rule editor, and then some best practices around developing the rules and structure and little bits of information pertaining to what we should be doing with our rules and the like. So moving forward here, as usual, my name is Tom Fitzgerald. I'm a senior implementation consultant at Autodesk. I'm an expert iLogic trainer. I also focus on Inventor automation outside of iLogic. And I also do a lot in terms of data management, so Vault, anything related to the manufacturing process of developing 3D designs, documenting 3D designs, supporting information, and of course, storing that information inside of the Vault. I've been with Autodesk for over 6 years now. I've been working in the manufacturing industry for 20 years now, using many different CAD applications, ultimately becoming an expert using Inventor. Today, we're going to be talking about the third aspect of the 4 aspects of design automation using iLogic. In previous webinars, we've talked about what we need to be doing in terms of model development, some of the pros and cons, the do's and don'ts of developing different models. In our last webinar, we talked about extending some of that functionality by being able to connect to different data sources, be it Excel spreadsheets or SQL database tables or the like. So how do we access that information? Today, we're going to be focusing on the third aspect. How do we go about developing the logic, some of the do's and don'ts and best practices of creating rules and using the rule editor? As stated in the last bullet there, we're going to be working specifically within the rule editor and what we should be doing about structuring our logic. So in previous webinars, I've shown this data flow, highlighting some of the other aspects that we've been working with today. As indicated here, we're going to be working with this center little area here where we're going to be developing the business logic and what it takes to do stuff like that, be it in iLogic rules or even in Visual Basic.net. So a little bit of a look at what it entails using Visual Studio to do kind of the same thing. So we'll get into that here in a little bit. So when working with rules, one of the first things that we need to understand are there's 2 different types of rules that we can develop within iLogic, and they're going to either be internal rules or they're going to be external rules. And you may have seen this within the Inventor iLogic browser of, well, why should I create internal rules or external rules? Well, just a little summary as to why you would want to do one or the other. Internal rules, they live within the file. So you create a file, you develop the rules, they get stored in that file, you save the file. Wherever that file goes, that's where those rules are. So it's very specific to the type of file that you're going to be using, either a part file or an assembly file or a drawing file, as to what you want to be doing with that logic. So it's very focused on a set of files that you want to use automation with. One of the downfalls of that is the fact that those rules are exposed to any end users that might be using those files. So from an administrative point of view, or from a business policy point of view, maybe you don't want your end users being able to open up the rules and maybe manipulate them. We all have those individuals within our companies that if they see something that they're not quite sure about, they randomly start pushing buttons or investigate things, and you may or may not want that depending on the level of functionality that you're desiring or the type of security that you may have within your business. Okay. External rules, on the other hand, are maintained in some sort of directory, either local or centralized, so they can be somewhere out on your computer personally, or they're out on the network somewhere. This creates a possibility of being able to secure those rules. You may have some sort of business policy or network policy that might be able to expose those, and you may be able to prevent end users from being able to access that information through Active Directory folder policy or security. Okay, so external rules are not stored inside of the files themselves. They're stored centrally or out on the network somewhere, and then you can create a whole series of different rules that do very specific things. And we need to take into some consideration when working with external rules, simply because they're not stored inside of the file, so they don't inherently try to understand the type of file in which you're working with. So being external rules, they're more at an application level. So we need to take into consideration what files we may be using with those rules, unlike internal rules where we are allowed to make them very specific and focused. Okay. Because of the internal external rule type of variation there are some things that we might be able to do to prevent end users from being able to access internal rules, some security quote unquote workarounds. And I'll show you that here in a moment. And then get to know, you have to get to know the rule editor, some of the things that you can and cannot do inside of the rule editor. And maybe drill through there and try to understand some of the other wizards and functionality within the rule editor itself. So we'll get in that in a little bit here. All right, so when it comes time to developing your logic, some of the key things that you must do is you have to understand what it is that you want to automate. If we're working with drawing files, then we don't want to have to do too much with manipulating geometry within the part files. We want to do very specific things in terms of that drawing. You have to understand what steps are needed to accomplish a particular task. If you wanted to, develop, let's take that drawing example, that drawing views example. And if we want to manipulate, or rather create views of an assembly or of a part, then we want to be able to understand the steps that Inventor inherently uses to go about that same process. By understanding Inventor and the steps it requires, developing the logic is going to be that much easier. Understand what it takes to accomplish these tasks using the Inventor API. Going back to what I was just saying, if you don't understand Inventor and the tasks and the steps that Inventor requires in order to automate a task, then there's going to be a lot of frustration and a lot of confusion. So first and foremost, when working with any type of logic, you have to understand the application in which you're using as an engine to drive that automation. Okay. Some key things that I'm going to touch on here in a demonstration in a moment is when working with iLogic, because of the fact that it's based on the VB.NET language, you should probably try to use common code writing techniques. And these are everywhere on the internet. Do a Google search for anything that you might want to do in terms of the Inventor API, and there's tons and tons of different examples of how to get it done. And a lot of them may get you to the same result. They may be a different path to get you to the same place. However, the techniques used might vary somewhat. However, ultimately, if you boil it all down, there's a lot of very common code writing techniques that should be followed. Some of those are use subroutines and functions, just like what we would do if we were going to be using Visual Studio. You can do the same thing using iLogic Rule Editor. You should structure rules very similarly. In terms of how should you create your variables and your different parameters, I highly recommend using Camel Case. If you're unsure what Camel Case is, you can once again go on the internet, do a Google search for Camel Case, and it clearly defines what that is. I will also show you that here in the demonstration momentarily. Also, shared variables. Another feature within the iLogic Rule Editor, creating shared variables. Shared variables are somewhat different than regular variables in the sense of iLogic. When you create variables, they're used typically within just that rule itself. So you initialize a variable, you give it a value, and then you utilize it, maybe altering the information associated to that variable. Shared variables are an application variable. So you can set it at the beginning of a process. You can use it throughout all the rules if necessary. And then at the end, you can clear that shared variable to reinitialize it later on if you need to. So the takeaway of this particular slide here is you should think of the rules as subroutines. Break them up based upon the type of task or step that you're trying to accomplish. Don't try to put every single function and every little step in one big rule. It doesn't help with performance very much. From an editability, from an editing point of view, if somebody else has to manipulate or edit the rules, it's very difficult sometimes to be able to find what it is that you're trying to edit. Or, as we all know with iLogic and working within the rule, there is no debugging type of mechanism in iLogic. So if you can break up your rules and you can classify them and you can organize them, when it comes time to having to debug or alter the rule functions, it's going to be a lot easier if they're broken up. So think of your rules as subroutines, okay? Here we go with the live demonstration. So if I'm going to pull up Inventor here, so we can see this is an assembly that I've been using throughout the different webinars. I've added and tweaked a little bit here and there to kind of demonstrate more of the functionality that we're trying to show within these webinars. But for those of you that are not familiar with what I've done here previously, I have a series of different rules here that go about creating a configuration. And this is very specific to the utility industry. So obviously it's a very good demonstration example because it kind of keys in on a lot of the basic aspects and those things that we want to derive from using iLogic in terms of an automation. So by going through these steps here, I'm actually I wrote the code in such a way where we don't build up a model initially and then turn things off if we need them or do not need them. This builds a model from nothing to something by going out to a pool of parts and pulling in just the necessary parts that are for this particular configuration. So I don't have anything suppressed, I don't have any visibility turned off. The only thing that exists within this assembly is what's required for this particular configuration. So it's boiled down to just the necessity, okay? So I have these two buttons here, update configuration, apply configuration, that essentially just run different rules. And those rules are broken up like this, okay? So here, back in the iLogic browser, we have rules. If I need to create a rule, I can add a rule by right-clicking on there. So these rules here are internal rules. These are stored within my template here. If I wanted to create external rules, nothing more than go into the external rules tab. I can right-click and say add external rule or create a new external rule if I'd like. And these files, these are stored out on a network, and I'm telling Inventor where to look for these in my options. So in my tools, if I go to options here and I'll go to iLogic configuration, this is where you define your external rule directory. So by default, I believe they go into your users directory, but in a production environment, in a large engineering environment, you're going to want to centralize these external rules, and this is where you would do it. You can add that directory, host all of your rules in that directory, and then through your application options, you can make sure that all your end users are utilizing those same rules, okay? So now that we have internal and externals kind of defined there, let's talk about our rule structure. So I have a few rules here that do very specific things, and that's how I have them broken up. So in this first rule, if I open this guy up, it doesn't do much. Let me bring it over here. It basically just sets a series of variables. So here's that shared variable I was talking about. Shared variables, like I said before, are application variables, application level. So in this sense, in this first rule that I've created, I'm setting a variable that I'm going to use throughout my process, okay? And it's nothing more than under my variables, in a browser here, under my variables or classification here, I have where I can create a shared variable. I can see if a particular shared variable exists. I can remove them. So if I need to remove it at an end of the process, I can, or I can remove them all if I need to. So by using a combination of these variable snippets, I can check to see if a variable exists and what its value might be. I can initialize a variable or create one on the fly, and then I can remove them or clear them as necessary. So this is a very good methodology to use throughout an entire process, as opposed to just utilizing a variable within a very specific rule. And a good example of that would be what I have right here. So I'm creating a variable called button click. I'm telling it to be the value of this message box. So it's either going to be yes, or it's going to be no, or depending on how I have the message box created, it could be okay or cancel, whatever the case might be. And then whatever that value is here, that's what I'm checking for conditional in order to run the rest of this rule. So this is not a shared variable. It's a variable that only exists within this rule, and it's only going to be applied there. So if I need to use the value of that variable in other rules, I would want to use a shared variable to accomplish that, okay? Some other things that I've done here. So collecting data and updating the work feature. So one of the processes that I need to do in order to understand what it is I want to do with my automation, one of the first steps I'm doing is I'm going out to my external data source. In this case, it's an Excel spreadsheet, and I'm going to bring in all the necessary information that I need at one shot. So all my information is going to be there. Depending on what I've selected, will then determine what my final values are going to be, and then I use those values later on. So in this rule, I'm not using any shared variables in order to hold values. In this case, I'm actually using parameters. So we're very familiar with creating user-defined variables and parameters. Those also are nothing more than placeholders at the file level. So I can populate those parameters and then use those parameters later on if I need to. So it's just different mechanisms to identify information and then store that information so we can use it later on. We could store that information by using shared variables. We can use it by using parameters inside the files. In this case, I've also used an Excel spreadsheet as an external database to store that information. So it's whatever mechanism you choose to use in order to store that information to use it later on through our automation. Okay, so collecting, so like I said in the beginning of our webinar here, you want to structure your rules based upon the type of task or step in which you're trying to accomplish. So all this rule does here is it goes out to that external data source, that Excel spreadsheet, grabs the relative information that I've defined within the rule to update my work features, my work planes. My work planes in this example is what drives the location of all of my components. So instead of bringing in a pole or bringing in an insulator or bringing in a fastener and then constraining it to another part that may or may not exist, I constrain, in this example, I constrain all the components to work features, and I've identified those work features as work planes, work axes, and then work points. And I've also renamed them so I can use them and identify and find them later on throughout my process. So this is a very important thing to understand. And we talked about it previously in our model development, is use work features as much as you can. And also come up with a good naming convention so you can identify your work features. So inside of the rules, you want to use a good naming convention in terms of what you want to call your variables and your parameters. So as an example, I'm defining a variable here called XL data source. Here's one where I use a full name, so find the double circuit. So you don't have to, sometimes you can get away with abbreviating or using acronyms for your parameters and your variables, but over the years I've learned that you want to try to clearly identify. So don't be afraid of using longer variable names or parameter names. Go ahead, because you want to be able to clearly identify which ones are which so you can find them later on, okay? And then this is a good example of camel case right here. So find double circuit. You'll notice that the first word, find, isn't capitalized, but double circuit, double is capitalized, and then circuit is capitalized as well at the beginning to delineate between words that make up my parameter name. So pole config, line guard config. So I try to use clear English in this sense to be able to identify what I'm trying to do, okay? Going here to, let's go look at clear components. So this is a routine or rule that I created that all it does is it clears out the components inside of this rule, okay? Or inside of this assembly. So it basically just goes through all of my components in the browser, in the model browser. We have a collection, which is all of the occurrences in the current assembly, and then we're just going to go through and delete every single one. So I've created a loop here that goes through all the occurrences within the assembly and then deletes them out of the assembly. As a secondary process, if there's a folder called fasteners inside of the browser, it's going to go and delete that as well. And basically, it's just a mechanism that I have here to clear out my assembly. How does that work? I have all my components here in my assembly, and if I just run this rule real quick, clear components, it's just going to do exactly what I said. So I developed a rule that does one very specific function, okay? Now, I could have that in other rules and call it as a function. As an example, in this rule, I've done that, where I have a series of different functions and subroutines that do many different things. So if I collapse all this here, we get a better understanding as to what that looks like. So I've labeled these different functions, so that way I can expand and collapse them. But you'll see that I've broken them down into exactly what they do. So this particular function, all it does is add the occurrences that I've identified to a specific folder. This function right here, all it does is it constrains occurrences. This one above here, all it does is add occurrences. So I've broken them up into very specific tasks, just as you would do if you were an end user doing the same thing. Think about the process in which you're trying to accomplish. If I needed to bring a component into an assembly and properly orientate it and constrain it for my process, it's very specific in what I have to do. I have to browse out and I have to find a file. Once I have that file, I have to place it inside of my assembly. Once it's placed inside of my assembly, I have to orientate it and apply different constraints to make sure that it's positioned relative to all the other components within my assembly. So I'm doing the exact same thing that you would do manually, just in an automated fashion. A couple pros here in terms of how I have this structured is the fact that if I need to come in here and debug something, or if I need to understand how something is functioning, I can collapse all that other information, just focus on what I'm trying to accomplish by going to that particular function. One of the cons that I found in this particular example, this particular rule, well, you know, if I look at it thoroughly, I think I could have done this a little bit better. I think I could have broken this down or broken it up into different rules a little bit better. And what I mean by that is what this rule is doing very specifically is I'm bringing in information, and then I'm kind of interpreting that information. And once I have that information interpreted, based upon if what I'm working with is a bolt kit or if it's a line guard or a clamp, I have to go through that information and interpret it first before I can do the add occurrence or add constraint or add occurrences to folder. So in all actuality, these last three functions probably should have been in their own separate rule, while these functions up here do very much the same thing. They just have a different identifier to understand which function I put that component through. So I could have done a little bit better in that sense, but ultimately what I'm trying to get at here is you want to break up your rules into their particular task. And in all actuality, there's nothing wrong with even trying to, or even taking each one of these functions and have them as their own rule. That way you have a very specific focused set of information or rule writing information, rule information that you can focus on in order to try to manage what that code does. So some of the other questions I've had about that is, well, if I have all these rules, how do I control which ones get fired? How do I control the order in which something gets fired? Well, there's other things that we can do in that sense. If I look at, is it this? No. Let me go through this process and then I'll show you something else that we can do in that sense. So if I go here to my forms, I'm just going to run this guy, update my lists. Now I have my lists updated, everything's good to go. And I'm going to update my configuration and build this yet once again, okay? So I'm going to build this configuration, I'm applying it. After this is built, then I'm going to go through and you'll see a third button there that I've added since the last webinar is called Create Drawing. So this has always been a big deal. I have this mechanism to go and I can create my assembly. How do I go about creating the drawing? So I'm not going to go into this. I'm thinking about actually having this as an additional webinar focusing just on drawing automation. But just to kind of give you a little bit of a teaser, what it's asking me is what drawing or IDW, what drawing file do I want to use in order to create a drawing of this particular assembly? I've identified that. You could hard code that. You could not make that as a user selection. If you have very specific templates, you could automatically identify that template. In this particular example, I wanted to give the end user an option. Which template would you like to use? And then after that, let's prompt the end user, would you like to open up now or would you rather open it up later? If I select yes, it's going to open up that drawing, which I've saved in the same location that the assembly exists. And now that I have that, I have this other button here inside of my drawing where it's going to run a series of rules to take that assembly that I just have associated to this drawing, create some views, scale them, position them, bring in the bill of material, and add just a few dimensions just to kind of give you an idea of the capability of what rules can do inside of iLogic. So what does that look like? I have a series of rules that do very specific things, like save a copy of the template and keep the reference to the assembly in which I have, add the different base views as necessary, add the bill of material, add the dimensions, and if I go back and I edit this assembly, add some components to it, I may want to update and reorder the BOM items. If you'll notice in my BOM here, I have a bunch of item numbers, but they're not really ordered the right way. So I can run this rule, which will then take that information, make sure it's ordered properly. So just a few little examples of what you can do with the rules. And what I was talking about previously about rule order is if I go into this rule, I'm doing something very specific in terms of identifying the base views and what they're going to be called and where they're going to be positioned. But you'll see here that I have this iLogic VB run rule, and I'm calling a very specific rule to run in a very specific order. So you can go and create all the different rules that you need that do the very specific tasks or steps in which you need them, and then you can call on them as necessary. If you don't call on them as necessary, and you leave your rules unsuppressed, so right now, excuse me, I have all my rules suppressed because I don't want them to fire at random. I don't want them to fire upon property change or parameter change or anything like that. I want to leave them suppressed so that way they don't fire automatically. I want these rules to fire when it's necessary. And typically it's I typically try to create some sort of linear process where a rule will fire, and based upon a particular condition, it will then initiate another rule to fire or a series of rules to fire by using this mechanism right here, this method of iLogic VB run rule, and then identify the rule that you want to run. There's nothing to suggest you couldn't put this in a conditional expression like if then, or a loop or a try, where if a value equals something, then run this rule. But if that value equals something else, then run a different rule. So in terms of understanding your rule order and the synchronization or the order in which your rules fire, this is the way that you would want to do that. Okay, if you break it up and you organize them in the terms of function or in subroutine, that goes a long way as well. It really helps out in managing that that flow of information. How do I make my rules run a particular way? Okay. So working here inside of the rule editor, we have a few things that we can do. So if you've opened up iLogic before, you're very familiar with these snippets. And I've talked about them before, but I just want to be very clear as to these are the snippets that just come with iLogic. This is not by any means all of which iLogic can do. This is just some examples that as an end user you can use to get started and get a basic understanding of what iLogic can do. Okay, iLogic is nothing more than, in the way that I look at it, iLogic is nothing more than a window or a door to access the Inventor API. And that's what I do with all of my iLogic coding, is I try to structure it very similar to VB.NET code writing practices. I declare all of my variables. I give them a particular value and initialize them. Then I use them. In this case right here, delete base view O-sheet. This is, I'm calling a function and I'm passing a value to that function. So delete base view is a function that I have right here. And its process requires, well, what sheet do I want to delete the views from? So I have to pass that variable to that function in order for it to go through each of the views inside of the drawing to be able to delete those views. So common code writing practices: declare all your variables, give them, understand what type of classification are they, what kind of variable is it, what kind of value is it going to be holding, and then go through the process of, is it something that I want to use from a shared variable? Is it something that I want to use from a parameter? Is it something that I want to access from an external data source? However your process is of storing that information, make sure that you're applying that and giving your variable some sort of value. I even have, let me see here. I think I have something I can show here. Well, maybe it's down here. Nope. Okay. Either way, when declaring your variables, like I said before, you should try to give them some sort of value. Don't leave your variables open. Like, As an example, one of the things that I can do, if I just go down here into this area, I could say I want to declare a variable as a string, and I could say, I could just leave it like that. Now it's a variable, it's an empty string variable, it doesn't have any value. Or what I like to do is I like to do this. And now, by doing something like that, now I've declared my variable, I know it's of a string type, and it's empty, so it doesn't have any value. So if I go through my process and it's just a more thorough way of being able to identify and understand what it is your code is trying to do, particularly with variables. Because iLogic doesn't care. I could write that variable string like that, or that statement like that, or I could just say variable, if I could spell right, equals, this is a variable. Okay, so now just by doing that, iLogic understands that variable is of a string type and it has a particular value. So iLogic doesn't care. However, if I was an end user and somebody else had wrote this code and I wanted to update it or debug it or add additional functionality, that may be confusing to me. I may not understand that as well as if I would have written it out as a declaration, giving it a particular type as a string or as a double, and then giving it a value. What I'm trying to get at, guys, is this is much more readable. It's far easier to understand than if I had not declared it. And it creates some level of a standard. If you have standardized code writing practices, that just makes it easier for everybody else to be able to understand what it is you're trying to do. You know, I'd watched a video not too long ago of a gentleman that was teaching a class on writing C#. And one of the things that he led off with was that when it comes to writing code isn't so much for the software to understand what to do. It's very much more for the person or the human being that has to try to understand that. Here's step 1, here's step 2, here's step 3. Each one of these lines is literally a step that the code has to go through. But if you can write it many different ways, and if you don't write it in such a way that is understood, it's going to be that more complex and that much more difficult going forward, especially as you start getting into these very large, complicated automation projects. You know, my example here is fairly simple in the grand scheme of things of what it's trying to do. But as we get more complicated and with a lot more moving parts, having some sort of standardization in terms of your code writing is going to be very, very critical. Okay. Also, lastly, as we talk about rule writing and code writing, as you can see within my writing here, my code, my rules, I have it broken up into different subroutines. I have different functions that I call from those subroutines to do particular activities. By following best practices and common code writing practices, I can take anything that I've done here in iLogic and I could take it over to, you guys are going to love this, I can port this over to Visual Studio. So here in Visual Studio, I have a solution that I've created that has a form that goes through the same process of I open up a drawing, I create my drawing views, I select my view scale, I crop my views, I add a parts list, and I add different dimensions and create those linear dimensions as necessary. So exactly what I've done in iLogic, I essentially took these rules right here, did a copy and did a paste inside of Visual Studio to do almost the exact same thing. So let me show you what that is here in a moment. So if I go to Inventor, what I'm going to do is I'm going to shut this down just to kind of give you guys an example of what this does. So if I close down Inventor, I'm not going to save that. If I close down Inventor, And I'm going to go back over here to my Explorer here. And in here, I have this solution. I've built a solution from Visual Studio into this executable called create DWG from assembly, okay? And it uses the exact same subroutines and functions. I had to manipulate the code slightly, and I can show you what that is. But essentially what this does is I do not have Inventor running right now. I don't have any session open. What this does is, as I double click that, it's going to first check to see if Inventor is running. If it is, it's going to use it. If it isn't, it's going to fire it up. And that's what just happened here. So it monitored to see if Inventor was running on my machine. It isn't, so it fired it up. And now it's asking me, based upon the form that I generated, to browse out for an assembly file. And I'm gonna just select this assembly file. It was just saved a little while ago, so I know it has content in it, or I believe it has content in it. If I go ahead, hit open now, it's going to take that assembly file and it's going to go out and it's going to use that drawing template that I created. It's going to bring in those views. It's going to scale the views. It's going to position the views. It's going to crop this view, bring in the BOM, and add the dimensions. That did not run from iLogic rules. That ran exactly the same way. However, it ran from my Visual Studio solution, which used my iLogic rules. So these are straight up copied right from my iLogic rules. The only thing that I had to do differently was when I called Inventor, as opposed to calling Inventor from the this application, I basically changed that to a different variable called Inventor app, and it's the Inventor application. So aside from maybe about 3 or 4 lines of code where I had to replace this variable, it was straight up just a copy paste, organized it into the different routines, and it did the exact same thing from an executable, an external application that somebody can just fire to do the exact same thing. They're not exposed to the rules. They don't get to see the rules. They cannot manipulate the rules. You give them as an executable and does the exact same thing that the iLogic rules would do inside of the rules that I created here for my Inventor automation. If I go and kill this, now if I kill this form, which one of the activities that I have in that form is if I kill the form, it kills Inventor, closes down the file and everything else. So now it's asking me, do I want to save that? I'm going to say no, and it's going to exit Inventor for me. So that's just an example of what you can do with your rules if you follow some best practice policies. So let me open up Inventor once again here, and we'll finalize some of the demonstration here, and then we can open it up to Q&A here. So let me open up my example once again. And here's my drawing that I created previously that has nothing in it. That's not what I wanted. This is what I want right here. All right. So as a summary of what we've accomplished and what I've demonstrated today is I hope that you had the opportunity to take away some of the things that we talked about, is understanding the steps that are required for automation. You know, if you don't understand Inventor and you don't understand what it is that you're trying to accomplish, you're going to have a very difficult time understanding what kind of rules that you need to create and the structure in which you create those rules. Okay. Maintain common and well understood writing methodologies. Even though you don't need to be a coder per se in order to write iLogic rules, you know, we have a series of snippets that are in the rule editor that will allow you to get started, to be able to allow a basic end user to be able to, you know, apply some really rudimentary and basic automation. If you should at least understand some of the best practices when it comes to VB writing methodologies. And a lot of that information is out there on the internet, YouTube videos. There's a website called Stack Overflow that I use on a regular basis. There's some good information in there. And finally, you have to know the Inventor API. You have to know Inventor. If you understand the Inventor API, it's going to make it that much easier. Almost all the code or rules that I write now are based upon the Inventor API. Very little of it exists, or very little of the code that I write do I use the iLogic snippets, simply because they're more or less shortcuts to the API. If you understand the API, you don't need to use the shortcuts. You can just write directly from the Inventor API. And then, of course, we have a couple more webinars here in the future. So if you find this information interesting and compelling and you want to learn more, please stay tuned. Follow more of the webcasts to get more information. Some of the things that we're going to be doing in the future pertain to developing user interfaces and how do we interact with end users to get input from them. And then also, I would like to do a webinar pertaining to drawing automation, because that seems to be a very hot topic nowadays. So Nigel, with that, if you want to open up to Q&A, please feel free.
Yep, certainly. We do have a couple of questions that came in. If you do have a question, go ahead and type that into the chat box at any time right now, and we'll be able to address those. So there's a couple of questions here. Some of them actually relate to each other. First one being, as far as best practices go, is it more beneficial to write code directly in Visual Studio or in the rules editor to use the debugging tools in Visual Studio? Or is it best practices to just go straight into the rule editor, do everything in there, and then maybe port to Visual Studio later?
I think a lot of that comes with comfortability. So if you're comfortable with using Visual Studio and you understand VB.net and you want to get a better understanding into the Inventor API, by all means use the Visual Studio environment, simply because we have IntelliSense there. It informs you if there's things that it doesn't understand. You can create different references to the Inventor and iLogic applications. So I would, if I were a new user and I really wanted to understand and work with Inventor automation, your best bet starting off is become familiar with the Visual Studio IDE. Become familiar with VB.net. As a matter of fact, you don't even need to use VB.net. If you're going to use Visual Studio and you're more comfortable using C#, C# being a .NET framework application, or language rather, you can still use C# when working with external applications to drive Inventor automation. So it all depends on the the language in which you're most comfortable, but by far and away, the Visual Studio IDE is much easier to use in terms of debugging.
Certainly, certainly. Thank you for that. That answers like 4 questions, so I guess we killed multiple birds with one stone there. Another question here in regards to someone's actual usage of iLogic. When I use iLogic to change dimensions in my model, the update command only updates when I finish the rule. Is there a way for this to prompt or to execute before I actually end the rule?
To prompt an update?
Yeah.
Yeah, you can use update anywhere within the rule. A lot of times, as a matter of fact, depending on the complexity of your rules, you may want to update different parameters and properties and then update the file before continuing the rule, because you may have other code within the rule that is dependent upon updated information. And as an example, let me show my screen here once again. So if I go back here into Inventor, you're going to see, if I just go into any rule, one of the things that we can do is we can do, under document, we can do update. So update when done is one way to update a rule or update a file. So it updates the document after running the rule. So no matter where you put this in the rule, it's only going to update at the end, okay? Then you can do an document update, which it runs at, or it updates at the line, at this particular statement. So if you have document update in the middle of the rule, it will update at the time that it reads this line, okay? These two, rule parameter output and document update, work in conjunction with one another. Rule parameter update. So if I'm doing something within the rule that is going to update parameters and I want to update that information, it is updated. I may change that value in memory, but it may not have updated in the sense of where iLogic wants to use that information. So if I make parameter changes and I'm manipulating parameter information, particularly if I'm working with reference files, so if I'm trying to update information from a part and I want to use that information in an assembly, I want to make sure that once I manipulate and change those values, I do an update and then I output those updates to make sure any reference files get that new information at runtime, okay? So I may have a series of 5 rules. Maybe in rule number 2, I'm making some changes. In rule number 3, I need to use that change information. So I want to make sure I'm updating everything so I have the latest and greatest information before carrying on with the rest of the rules. So rule parameters output and document update are the 2 things that I would use in that particular situation. Otherwise, update when done, just updates everything at the very end. Very good. I've seen situations in the past where end users weren't getting the desired result. And what I mean by that is they would make some parameter changes or property changes, and they would do an update and then they wouldn't see the changes, so they would do like multiple updates. They would do an update and then the next line would be another update because that way they got the desired result. That simply has to do with the way that when they're updating and when they're changing information, and of course, is that information changing locally or is it in a referenced file, okay? So there's different scenarios in which you would want to use these, but if you ever find yourself where you're getting undesired behavior in terms of your updating, like you have to do multiple updates to get the desired result, and what I mean by that is I've seen people do something like this, where they do an update and then they do an update when done, or they do multiple updates to get the desired result. If you're finding yourself in that situation, clearly something is not right, because you shouldn't have to do multiple updates like this. Typically, it has to do with the fact that you're not outputting the updated information. Rule parameter output.
Certainly, that's a big help. I ran into that issue personally. I'm trying to do something, so that's definitely helpful for even me. So let's see here if we have any more questions here. Let's see. Is the next webcast scheduled? So no, the next webcast is not scheduled yet. We have to track down Thomas here. He's a busy guy. But we'll certainly have that scheduled probably by the end of this week. We'll figure out when that's going to be, and then just be on the lookout for that email. And then Thomas, do we know what the next one specifically is going to be? Do we know if we're going to do drawings or we're going to go into forgot what else?
The next one will be user interface and user input.
That's what it was.
Yep. So developing forms using the iLogic form editor, and then of course using Visual Studio to do the same thing, to create different forms and UIs. Perfect.
I think that's it for questions. I'll give everyone another 20 or 30 seconds or so to type out any last ones that they need. But just know that, hey, we're here. If you do need us, you can email us, lifeline@ketiv.com. You can even call that phone number. Or you can even reach out to us via, the questions or the surveys during all of these. I make sure to go over them again, see if I missed anything in general. But if you think you have a product line that is ready for automation, or you think it might be a good fit, you just want a little bit of advice on whether or not that is the case or so, definitely reach out to us. We're more than happy to schedule some time with one of our engineers to talk to you and your company to see, if iLogic or leveraging the Inventor API might be a good idea in regards to automating some of your processes. So with that, I think that's it for today. Again, Thomas, thank you for being here today, and we'll hope to see you soon for another webcast.
Absolutely. Thank you for your time, guys. Appreciate it.
Yep, and thanks for everybody for watching us every week. And hi, Mom, when you watch this recording, I guess if you do watch the recording. But we'll see y'all on the flip side next week for some Nastran in CAD. I believe we're going to go over some static simulation and fatigue. So it's going to be a great session. Jorge Fernandez here at KETIV is going to be doing that for us. And we'll see you then. Thanks, everybody.